All right, everybody, good evening. My name is Zion Chung, and it is my great pleasure to represent Austin Thermal, the first medical device company to ever participate in Longhorn Startup Labs. Now, our company is focused on the development of cost-effective thermoregulatory solutions. Specifically, our team is working on a device for the treatment and prevention of hypothermia. Now, you're probably thinking to yourself, I know it's cold today, Zion, but I mean, we live in Austin, Texas. We're not going to catch hypothermia anytime soon. But the human body is very susceptible to catching hypothermia, especially when going under physiological stress, shock, or surgical procedures. Now, normal body temperature is defined at 98 degrees Fahrenheit. You guys probably know this. But it's regulated through a number of mechanisms like shivering. However, when you go under extreme amounts of stress, an accident, physical trauma, or surgical operation, your body can no longer use these mechanisms to keep it at that sweet spot in 98 degrees Fahrenheit. So your body starts to slip down. Once it drops just 2 degrees lower, at 96 degrees Fahrenheit, you start to experience the adverse effects of hypothermia, such as blood vessel constriction, vital organ failure, and muscle discoordination. Now, this translates in the medical arena to a 200% increase in post-operative infection incidence, a 20% increase in hospitalization length, and 55% increase in morbid cardiac events such as stroke and heart attack. So what do they do about it? Currently in the US, many medical staffs are using a stopgap combination measure. They try to wrap the patient up in electric blankets, try to stuff hot water bottles around him in the bed just so they can keep him up to that 98 degrees Fahrenheit. However, you can imagine how this is very difficult to translate throughout the continuum of care. You can't stuff water bottles everywhere when you're bringing the patient from the field to the ambulance, to the operating room, to the post-op room, to the ICU, to the outpatient room. It's very, very difficult. So the industry and some of these competitors have tried to use a standard IV to deliver warm fluid to treat this. However, these competitors have very many shortcomings regarding their heat loss, their lack of portability, and their very high initialization time. Austin Thermal is working on a device called Hot IV that will address these issues. Now, just to give you a very brief overview of how our device works, IV fluid flows from an IV bag into this cartridge across a resistive heating element. There's a separate external controller unit that regulates the power delivery to this resistive heating element in order to therapeutically warm the fluid enough to the correct level so that when it is warmed, it immediately goes into the patient, thus helping treat hypothermia, as seen in this image. So currently, we are at an alpha prototype stage, and our team is working to continually develop to a production level stage. Now, we plan on focusing on 3 technical aspects, the first of which is accuracy. Our team is working to optimize the thermal efficiency transfer within the heating element in the cartridge, as well as redesigning the entire fluid pathway in order to minimize that heat loss that our competitors suffer from. The second of which is portability. Our team is also designing the device to minimize the amount of material and the size that the device takes. As well as our electrical team, they're developing the power controller in order to be able to accept several modes of power along a very wide range. This is especially important when you're traveling, when the patient is traveling from the field to different ambulatory vehicles, such as a helicopter, regular ambulance. When you get into the operating room, all of these have different power sources, and it's very essential to continually deliver therapy to the patient during this very critical time. And lastly, initialization time. Currently, devices now take up to 15 to 30 minutes, even an hour, to prep this fluid in order to treat the patient. Our device, because of this minimal fluid pathway line and our simple user interface, it's a point-of-use device, so anybody can use it anytime, anywhere. So after initial preliminary studies about the IV market, we found that there are 1.3 million IVs started daily just in the United States. Now, 300,000 of these can benefit from warming applications, which translates to a $2.2 billion market, averaging at an 11% annual growth. Now, Austin Thermal plans to not start and tackle the entire United States at once. We're Austin Thermal. We're going to start in Austin locally, trying to integrate our system into the local healthcare communities. And then we'll extend past to Texas, and then potentially past to the United States. We've also researched a couple of market segments that our device is extremely well suited for, primarily the military. This is because they have a very strong purchasing power, a very readily available user requirement that we can design to. Additionally, we're going to be approaching the emergency medical transport industry. The neonatal ICU industry, because these babies are too small, they're born prematurely, but they're born with some disease, they can't maintain their own body heat, and so this puts them at a severe disadvantage when developing, especially in these first early stages. The veterinary unit and the general surgical operating theater, in order to lower the hospitalization time, lower the recovery time, and get patients back out there doing what they love. So this is the team behind all the magic: myself, Zion Chung, Ashwin Basham, George Nesher, and Emmanuel Nunez. The four of us are senior biomedical engineering students, all tied together through one driving motivation: our passion and our desire to increase and improve the delivery of healthcare through the creation of innovative devices like Hot IV. To achieve this, we partnered with a local, proven technology incubator, Texas Medical Accelerator. Texas Medical Accelerator has provided tremendous support and resources for our technical development. Additionally, because the medical device industry is so resistant to including new technologies, it's very difficult for new companies to try to penetrate this market. Texas Medical Accelerator has provided an ample amount of resources and has been invaluable in helping us establish connections within Seton Healthcare, the Seton Healthcare family, to establish these first initial lines of distribution. Lastly, we are Austin Thermal. Please feel free to contact myself, any of my teammates, if you are more interested in our technology. We'd love to hear back from you. Thank you.